State whether the following statement is true or false. Justify your answer. Point P is a point of intersection of y-axis and the perpendicular bisector of the line segment joining the point A and B. So let us understand this with the graph. So we have -1 and 1 and 3 and 3. So let us zoom in a bit and also make it okay. Does this look okay now? Is it a square? Kind of, right, guys? 0 and 0 are over here. Yeah. So basically this is our graph. So what is the question? The question is telling that, say we have a perpendicular bisector for this. So for this 2 points, that is the line joining these 2 points, we have a perpendicular bisector. So basically this is A and B, and say point M is our midpoint. So drawing a perpendicular line through this point will give us the perpendicular bisector. The question is, the perpendicular bisector and the y-axis, they meet at 0, 2. Is it true or false? Well, that is something that we can do. We can approach this in 2 ways. One is we can find the actual point wherein this perpendicular bisector is passing y-axis. That is one of the way. Or we can use proof by contradiction. Try to recall, where do we have proof by contradiction? Yes, when we are proving irrationality, we use it. So I'm going with the traditional one, wherein I'm telling we have point A -1, 1 and point B, which is 3, 3. And I'm going to assume few things. That is, I have a triangle and we have something like this. Doesn't look. So what kind of triangle am I trying to do over here, and what is the reason for this? Yes, we are looking at a perpendicular bisector. So these two lengths are equal, and this is 90 degree, and these two lengths are equal. So we have point A, we'll call this as M, and this is point B, and this we'll call it as T. So let me write a statement describing diagram. So let's consider T to be the point of intersection of perpendicular bisector and the y-axis. Perpendicular bisector of what? Of AB and y-axis. So because of this implies T's coordinate will be of the form, what guys? Yes, 0, y. So this would be of the form 0, y. And this is -1 and 1, and this is 3 and 3. So instead of given, I could have written this only. So let me shift all of this. Okay guys, that's better. And now we have M to be the let M be the midpoint of what? Of our line AB. And now on to solving this. So we'll tell as TM is a perpendicular bisector of triangle ABC, EBT. This implies triangle EBT is an isosceles triangle. Is an isosceles triangle with AT is equal to TB. Right guys? And so AT square is equal to TB square on squaring both the sides. On squaring both sides. So we have distance formula that we need to use, and that's how we'll figure out the value of y. So distance formula is what, guys? So distance formula is something that you guys have to write. I'm not going to write this. And now I'm going to substitute the values. So this would be, since we have squared it, it will be basically this are, what are the points actually? It is -1 and 0, so 1 square. So this is 1 square plus other point is y minus 1, the whole square, which is equal to, the other points are 3 and y minus 3 the whole square. So this we need to solve when we are done. So basically this is a minus b the whole square, which is equal to a square plus 2ab minus, wait, a square plus 2ab minus 2ab, wait, what? A square minus 2ab plus b square. So this is 1 plus y square plus 1 minus 2y is equal to 9 plus y square minus 6y plus 9. Okay, and then we have y square getting cancelled. This gets transposed and we have 6y minus 2y is equal to 18 minus 2, that is not 14, sorry, 16. So this is 4y basically. Anyways, this is 4y, this is 16, therefore y is equal to 4, is it not? So what does this imply? Thus 0, 2 is not a point on the perpendicular bisector, so the statement is false. Okay guys, so the statement is false, and that would be your answer. Okay, so here the main funda is again all of this, right? With this conclusion we'll be able to start that the distance of AT square is equal to distance of TB square, and then we'll solve it and find all of this. So any pattern or any question similar to this pattern, this would be your approach.